All right, today we are starting chapter 4. Our objective today is to classify triangles and find measures of their angles. If we need to come back to that at the end, we can. First up, we've got some vocab to fill in. A triangle is a polygon with 3 sides. I believe most of you already knew that. The interior angles are the angles inside. Interior angles are the angles inside of a triangle. Exterior angles, as it suggests, occur outside of a triangle, but it is more specific than that. So I will draw an example up towards the top of an exterior angle. Say we have this triangle, we have to extend one of the sides. It doesn't really matter which one. So I will extend this bottom side here. If I extend that out, it's not great, it's a little better. If I extend that out, then this angle here is my exterior angle. Okay, so an exterior angle will always form a linear pair with an interior angle. A corollary to a theorem is a statement that can be proved easily using the theorem. Through it. We can classify triangles 2 ways. The first way is by sides. We have 3 possible situations. First situation would be a scalene triangle where no sides are congruent. The second situation would be isosceles, where you have at least 2 congruent sides. And the third one is an equilateral triangle where you have 3 or all congruent sides. We have 4 ways of classifying triangles by their angles. First up is acute, if all 3 interior angles are acute. Second is a right triangle. Only one right angle needs to be present for it to be a right triangle. Next is obtuse. One of the angles inside the triangle needs to be obtuse. And the last one is equiangular, where you have 3 congruent angles. Technically, equiangular triangles are a specific type of acute triangle. Oh, I'll write it over here. So this is a type of acute triangle. However, if you are asked to classify them, if it is equiangular and you write down acute, it will not be correct. We have to be as specific as possible. So even though equiangular triangles will end up fitting the description of acute triangles, equiangular is more specific, so that's what we would have to go with. So anytime you have a triangle, you should be able to classify it by its sides and by its angles if you've been given enough information. One thing we might learn as a theorem later, and I'll just mention it right now, would be that equilateral and equiangular triangles always happen at the same time. If a triangle is equilateral, it's going to be equiangular. If it's equiangular, it's going to be equilateral. That pair always occurs together. First up, we've got the triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180 degrees. So we could create for ourselves some generic triangle, ABC. So this theorem states that the measure of angle A plus the measure of angle B plus the measure of angle C is always going to equal 180 degrees. If you add up the three angles inside of a triangle, you will get 180 every time. If you're finished with the triangle sum theorem, flip over so that you can copy down the exterior angle theorem. The exterior angle theorem states that the measure of the exterior angles of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So I'll get us another picture for that. Actually, instead of using letters this time, I'm just going to use numbers. We'll make it a little bit easier. Okay, so for this picture that I drew, my exterior angle was angle 3. So this theorem states that the measure of angle 3 is going to be equal to the sum, or addition, of the two interior angles that are not adjacent to angle 3. So that would be angles 1 and 2. So that means we would not use this interior angle right next to angle 3. The exterior angle theorem can be used, of course, to find an exterior angle. But if you are told an exterior angle, you can also use this setup to find a missing interior angle. The last little bit of information that we have is the corollary to the triangle sum theorem. That states that the acute angles of a right triangle are complementary. Complementary meaning that they add up to 90. Okay, and if you wanted to draw yourself a picture for this one, you can. I don't know that it's as necessary. But if we know that we have a right triangle, just label those angles 1 and 2. This corollary states that the measure of angle 1 plus the measure of angle 2 has to equal 90 degrees. This is a corollary to the triangle sum theorem because, of course, if we were to add in that right angle on both sides, we would be added back up to 180. So it's just a special case. If you know that you've got a right triangle, the other two have to add up to 90. Questions, concerns, or need more time on this slide? Okay. On to our examples. First example is to draw an isosceles right triangle. So isosceles means what has to be true about it? Careful. Okay, at least two sides congruent. For it to be a right triangle, it's only going to be two sides congruent. So we need to have two congruent sides, and what else do we need to have in our triangle? A right angle. So, start off with these two sides. These could be my congruent sides and form a right angle. How do I know for sure, though, that those two sides were congruent? Put tick marks in them, or if you would rather label them with some sort of measure, like put a 5 by both of them, you could, but I'm happy with the tick marks. Two sides congruent, and we have a right angle. Questions about one? Okay, now of course it doesn't have to look exactly like this. If you wanted to draw yours at some sort of other orientation, that would be okay. We could still have it be isosceles right, drawn in a different direction. Number 2 asks us to find the measure of angle DCB, which is this exterior angle here. We should all have degree symbols by them. I'll give you a second to get the diagram copied down, but I'd make sure you leave yourself some space to show some work. What kind of angle is angle DCB? DCB is an exterior angle. Do we know anything else about it? Atea? So we'll need to use that idea that the two interior non-adjacent angles will add up to that exterior angle. So we'll use that idea to set up an equation. It doesn't really matter to me if you want to start with the exterior or start with the interior. It's kind of up to you. So the exterior angle, the 2x minus 5, is equal to the sum of the two non-adjacent interior angles. So what would that be? X plus 70. Questions, concerns about how we set that up? If you put x plus 70 on the left and the 2x minus 5 on the right, that's fine. It's the same thing. To solve this, what will we do? Subtract x and do what else? Add 5. We'll just do it all at once. What does that leave me with? X equals 75. Good. Is that all we wanted was x? No. What do we need to do now? Okay, plug it back in to find the measure of angle DCB. So 2 times 75 minus 5. What's 2 times 75?
150.
Okay, minus 5 is 145 degrees. So that is our measure of angle DCB. Next up, triangle JKL has the vertices given. Classify the triangle by its sides, then determine if it is a right triangle. Okay. To do this, it will be helpful for us to graph it. So how am I going to get to point J? Left 2 down 1 is point J. What about K? Right 1 up 3. Oh, you're right. I didn't go over far enough. Thank you. That's better. Okay, and the last one, point L. Over 5, good. My K disappeared. Over 5. 1, 2, 3, 4, 5. For point L. Are we all happy with our triangle? Now, the first thing they asked us to do was classify it by its sides. Which means we need to know if any of our sides are congruent. Do you think we can do that based off of how it looks in the graph? No. What do you think we need to do? We got to use our distance formula to find the lengths of those sides. So I'm going to be doing my distance formula how many times? 3 times. We got 3 sides, we got 3 distances to find. Which one do you want to start with? Which one? JK? Okay, so remember distance formula, square root of x minus x squared plus y minus y squared. I don't really care which, if the 1s or the 2s come first or second, as long as we are consistent. So for JK, give me an x to start with. Okay, -2 minus squared plus, what y do I need to start with? -1 minus 3 squared. -2 minus 1. -3 square it is 9 plus -1 minus 3. -4 squared. Add them together, we get the square root of 25 is. Okay. So we know that JK has a length of 5. Which one would you like to do next? KL? Okay. Give me an x to start with. 1 minus. Okay, squared plus, what y do I need to start with? Minus 0 squared, 1 minus 5. -4 squared. 3 minus 0 squared. Add them together. Square root of 25 is. Okay. So we know that this could be what kind of triangle? Isosceles, but we still have one more side to check. So let's check side JL. Give me an x to start with. -2 minus squared plus, what y do I have to start with? Minus squared. -2 minus 5 squared plus -1 minus 0 squared. Add them together. Okay, that will simplify. Does anybody know what to, Majay? 5 root 2. Okay, 5 root 2. So if we're classifying it by sides, it is definitely isosceles. Okay, we got two sides that are the same, but not all three sides are the same. Then it says to determine if it is a right triangle. Now, before we do that, I am going to have to erase our distances to have some room to work that out. Do we have questions, concerns, or need the distances up there still? Okay. Distances are going away, so now we are thinking, how in the world am I going to decide if this is a right triangle? Well, which angle looks like it might be a right angle? Okay, kind of looks like it could be a right angle. The other two definitely don't appear to be right angles, so I would start with checking if angle K is right. What kind of lines form right angles? Perpendicular lines. So I need to check to see if which two lines are perpendicular. JK and KL. What do I need to find to decide if two lines are perpendicular? This goes back to chapter 3. There were times when I asked you if lines were going to be parallel, perpendicular, or neither. What did you find to determine that? They're slopes. Good, somebody remembered. We have to find the slopes of those lines to decide if they're going to be perpendicular. This time we don't really care about parallel. Obviously they are not if they touch right there. But we need to know, are these perpendicular or not? So I have to find their slopes. Who can remind me my formula for slope? Good. Okay, so let's find the slope of JK first. Give me a y coordinate to start with. 3 minus -1. If I started with 3, the x I have to start with is 1 minus -2. Subtracting a negative means we are really adding. So 3 plus 1 is, and 1 plus 2 is
3.
Great. So now let's work on finding the slope of KL. Give me a y to start with. 3 minus 0. If I started with 3, my x I have to start with is 1 minus 5. 3 minus 0 over -4. So my slopes are 4/3 and -3/4. Are these lines perpendicular? Yes, because their slopes are opposite reciprocals. Very good. So yes, it is a right triangle. So it is an isosceles right triangle. Put your little right angle box in the corner if you would like.
This is a long problem.
In fact, this problem is pretty short. Find the measure of angle 1 in this picture shown. Anybody find it? What'd you get? 19. So this is another one where the exterior angle, or 131, is equal to the sum of the two interior angles that are not adjacent to it. So 131 equals the measure of angle 1 plus 112. We subtract off the 112. And we get, oh, sorry. Didn't write that low enough. 19 is equal to the measure of angle 1. So that one's pretty straightforward. Do we have questions about it? Okay, so I know this slide said last example, but We haven't talked a whole lot about finding the missing interior angle. Now that one is pretty straightforward, but if, just for funsies, I were to create this triangle down here, and we'll just make it pretty easy. How would I find this last missing angle that I put down here? We'll call that also angle 1. Okay, add them all up, set it equal to 180, which means angle 1 would have to equal what? 60. Okay, so we just haven't seen one like that, but that follows that triangle sum theorem. Any three inside of a triangle have to add up to 180. Okay. We will